Standard 7th, Subject Science, Lesson number 18, Sound Production of Sound. Part 2. Children, in first part we have completed few points of this lesson. Now let's move to the next point. See, this is pendulum, and with this pendulum you have to perform one experiment. See, what you have to do is take a strong thread of sufficient length, tie wooden or metal bob to one of its end to make pendulum. Okay, in this way you have to make pendulum. Then after that you have to measure length of the thread in centimeters. Okay, whatever thread you took for this experiment, length of that thread you have to measure, and then you have to note down that. Okay, then suspend the pendulum freely from the support. Okay, and now swing the pendulum with the help of stopwatch. Record how many seconds are required for 20 oscillations. Okay, stopwatch, it is available in your mobile also. Then repeat this procedure 4 to 5 times. Okay, decreasing the length of pendulum by 10 centimeter every time. Means every time whatever first record of length you took, every time you have to decrease length of the thread by 10 centimeters. Then record your observations like this. Okay, see this table like this, you have to record all the observations. Suppose first time you took 60 centimeters thread, okay, and time required is 60 seconds only for that. Then for 20 oscillations it is taking 60 seconds, means 1 minute. Okay, but we have to count it in seconds only. Then time required, time period of oscillation, capital T, is formula is small t, that is in seconds, time required for 20 oscillations, divide by 20. So in this way you will get time required for one oscillation. So 60 seconds required for 20 oscillations. So 60 divided by 20 is equal to 3 seconds. Now last column is frequency N, which is measured in hertz, and formula is 1 upon capital T, that is time required for oscillation. So here you will get 1 upon 3 hertz. In this way every time you decrease length of pendulum 10 centimeters, and then you can note down observations. One more experiment is there. In this experiment you have to keep length of the pendulum fixed. Okay, that is 30 centimeters. Okay, don't change length of the pendulum, that is means length of thread no need to change, it will remain same, that is 30 centimeters. And here you have to take different amplitudes. Okay, different amplitudes means what? Last two positions, means the highest positions which is required, that you have to change, means B to C distance. Okay, if you will check the diagram, previous diagrams, B to C distance you have to change. Okay, first is small one, then little larger, then you have to take larger distances, and then note down observations. Okay, and if you will note down observations like this, what you will find, the conclusion from this experiment which you will get is the time period of oscillation T is depends on the length of pendulum, and time period of oscillation increases if length of pendulum is increased, and the frequency remains same even if the amplitude decreases or increases. Now children, look at this picture. You have to arrange the things like this. Okay, take wooden board, hammer two nails at both the ends and tie one wire on it. And then when you will plug that wire, you can hear some sound. Okay, and you can see vibrations also. But if you will put some wooden blocks in between, then you can see different types of vibrations and it will create some tension, okay, for vibration also and for sound production also, right? So this is what high and low pitch of sound. You can hear different type of sound when wooden blocks will be there or will not be there, okay? When the tension in the wire is increased, the frequency increases, and if the tension in the wire is decreased, the frequency decreases. When the tension in the wire is increased, the sound produced by vibrating wire is shriller, right? And on the other hand, when the tension is reduced, the sound is less shrill. And this is called the high and low pitch of sound. Next point is intensity of sound and sound level. Intensity of sound and sound level are two different quantities. The intensity of sound is proportional to the square of amplitude of vibration. If the amplitude is double, the intensity of sound becomes 4 times. Sound level is measured in units called decibel, which is written as small dB. It was named decibel in honor of the work of scientist Alexander Graham Bell. If the density of sound becomes 10 times than the original intensity, then the sound level is increased by 10 decibel. See children, here are some decibel levels of common sounds. Beginning of audible sound is 0 decibel. Normal breathing 10 decibel. Then murmuring from 5 meters away is 30 decibels. Then normal conversation between two persons 60 decibel. Heavy traffic 70 decibels. Ordinary factories makes 80 decibel sound. Jet engine 30 decibel. Start of ear splitting sound is 120 decibel. Hearing is temporarily affected by sounds of frequency greater than 1000 Hz and levels higher than 100 decibel. This can result in temporary deafness. Workers who work near aeroplane engines experience this. Now next point is audible sound. Which sounds we can hear? We can hear only the sounds whose frequency is in between 20 Hz to 20,000 Hz. Okay, therefore the sounds with frequency 20 Hz to 20,000 Hz is called audible sound. Next point is infrasonic sound. What is infrasonic sound? A sound having frequency less than 20 Hz is not audible. Just now we have discussed that we can hear between 20 Hz to 20,000 Hz. So less than 20 Hz is infrasonic sound and which is not audible to human beings. Therefore, the sound having frequency less than 20 Hz is called infrasonic sound. And sounds having frequency less than 20 Hz are produced and can be heard by whales, elephants and hippopotamus. Next point is ultrasonic sound. A sound having frequency higher than 20,000 Hz is called ultrasonic sound. See children, audible sound is in between 20 Hz to 20,000 Hz. Now infrasonic means less than 20 Hz and ultrasonic means more than 20,000 Hz. Ultrasonic sounds can be heard by human beings. Some animals like dog, cat, dolphin, sea lion, and bat can hear such sounds. Now, what are the uses of ultrasonic sound? To clean delicate ornaments and the tiny parts of a watch. To observe internal organs of the body. To detect tumors in the brain. To detect faults in a metal, in radar system. Then to kill certain microbes and insects. Next is sonar, that is sound navigation and ranging, is used to locate the seabed or the position of a ship. Now see children, frequency of sound. Just now we have discussed whatever we have discussed about infrasonic, audible and ultrasonic sound is given in this one, in this picture. See, 4 to 20 means what? Infrasonic it is written here, and blue whale can hear infrasonic as well as audible sound. Audible sound is heard by human beings. Yes, audible sound means what? The sound which human beings can hear. Okay. Then ultrasonic sound is produced by dolphin and bat. In this way we have completed this lesson. Thank you.